Hello, Algebra 1 Honors. Today we're going to look at surface area of prisms and cylinders, section 12.2. So, first things first, let's start with prisms. And so if you'll recall, a prism's kind of generated by taking a base and stretching it out. And so what you have is you have two parallel bases, and then the sides that connect those bases are called lateral faces. So let's label some stuff here. So this right here is a lateral edge. And so is this one. And so is that one. So in this case, when our face has three vertices, those will correspond to three lateral edges. And then, we've got lateral faces. Lateral faces. So drawing my arrows is kind of tricky here. So basically, can you guys see we got three different lateral faces here? I'll just kind of draw arrows to the middle. So we got one on front, one back behind there, and then one on the bottom. It's kind of hard to show. And then finally, the bases, I'll shade those in. The bases are the shape that's being stretched out to make a prism. So there's a base or bases. All right, so a little bit of vocabulary for you. So what I want you to think about is finding the surface area. A lot of people are like, well, they confuse surface area and volume, but finding surface area of a three-dimensional shape is, you can think of it as cutting a lot of the edges and laying it out flat and then measuring that area. So what that is called when you take it and you trim some of the edges and lay it out flat is it's called a net. And again, that can kind of help you to think about surface area when you're talking about three-dimensional shapes. So what we're going to draw is we're going to draw a net of a hexagonal prism. So again, a hexagonal prism means that its base is a hexagon and then it's stretched out. So what's cool is basically when you think of it, if you were to trim it and lay it out flat, well, one of the surfaces would be, oh, whoops, I about did an octagon. So let's fix that. So one of the ways to do this is to draw, let's draw, there we go. Draw your hexagon, 1, 2, 3, 4, 5, 6 sides. And then realize that you're gonna have a lateral edge coming off of every one of these sides. And you could make a star shape, but you see that I didn't really set this up for a star shape. Instead, what I want you to think about is I want you to think about trimming around the base, trimming around the base, and trimming on the base on the top, and then unrolling it. And what you'll have is you'll have a big rectangle. You'll have a big rectangle. So there's one of your sides. There's two more. 4, 5, and 6, because we're gonna have 6 lateral faces, and then we can trim for the other face anywhere we want. So there's a net for you. From there, we can start to think about how to find the surface area of any right prism. So to find the surface area, you're going to have to find the area of all these sides. So that's the area of all the lateral faces. But if you notice, it's turns out it's a rectangle, and that's going to be pretty consistent from shape to shape. And then how many bases do you have? You have 2 of them, and so that leads directly into our formula here. To get the surface area, it's going to be 2 times big B, which is going to stand for area of the base, plus the perimeter of the base times the height. So the perimeter will get you this length, and then the height of the prism will get you that length. Length times width for a rectangle. So perimeter times height gets you the area. So let's specify here where B is the area of the base. P is the perimeter of the base. And H is the height of the prism. All right, so if you'd like a little drawing, another drawing, we'll draw, well, actually, I mean, we could use the one up above here. Notice this one's laying on its side. So yeah, you would get the area of these triangles, right? Area of those triangles times, or area of one, double it. But then you'd need to get the perimeter of the triangle and multiply it by the height, which in this case, since it's laying down, would be the length here across there, the distance between the 2 bases. So that's how it's done. Let's move over to our first example here. Sorry, I don't have my usual setup. I've been I had to vacate my room, so I'm doing this, holding this by hand. I hope it's not too shaky for you. That's frustrating. But anyway, example 1 says find the surface area of a rectangular prism with a height 3 centimeters, length 6 centimeters, and width 8 centimeters. So the way they told us the height is 3, we're going to think of the bases as being bottom and top. So let's try the old formula out. Surface area is equal to 2 times the area of the base plus the perimeter of the base times the height. The area of the bases is going to be 8 centimeters times 6 centimeters. We're going to get 48 centimeters squared. The perimeter is going to be, they say it's a rectangle, so it's going to be 8 and 8, so 16 plus 12. 16 plus 12 is 28 centimeters. And then the height, the distance between the bases, is 3 centimeters. And then we multiply all this together. Yeah, and you'll get 96 for this, 84 for this. Notice it'll become centimeters squared, and then you add them up, you'll get 180 centimeters squared. Not so bad, huh? I don't think it's too bad at all. But here's the thing. You can have like a hexagonal, oh, here we got it. You can have hexagonal prisms, you can have octagonal prisms, you can have all those regular, regular polygons, all sorts of different regular polygons. And if you'll recall, to get the area of a regular polygon, you'll do 1/2 apothem times perimeter. So that's the situation we got here, is we've got these bases that are hexagons. stretched out 11 feet. So we've got our height there. But getting the area of the base, the big B, is going to be a little bit tricky here. So to get the area of the base, we're going to have to do 1/2 the apothem times perimeter of the shape. So the apothem is going to be this distance out to the center, right there. But how do we get that? It's a critical measurement. Now, it's kind of interesting here. These are equilateral triangles, I can tell, because the 12.8 is at the edge here, but it's also at this side. And whenever we draw the central angle, it forms, the radii are going to be the same. So I happen to know, I mean, I could do 360 divided by how many sides there are, and I can get 60 degrees for the central angle. But I already knew that because it turns out this is an equilateral triangle here. It's equilateral, and that means every angle is going to be 60. But when we draw that apothem down, that splits it up. So we've got a 30, 60, 90 in here. A lot of times I like to redraw that, but I don't think I'm going to at this point. So we've got a 12.8, a 6.4, and then to get our apothem, we're going to do special right triangles. It'll be 6.4 times a square root of 3 times the square root of 3. And I'll just do 6.4. Turn on my calculator. 6.4 times. Oh, I'm a goofy goober. I'm not going to multiply that out right now. I'm going to leave that alone because I have more computation to make. So I'm just going to leave it as that, 6.4 square root of 3. But now to get the area, it's going to be 1/2 that, 6.4 square root 3, times the perimeter. And our perimeter is going to be 12.8 times 6. So it's going to be 76.8 feet. So 76.8 feet will go right there. And I can simplify this out. I guess I will. So 0.5 times 6.4 times 76.8. And my area, I guess I should maybe call this B. My area of my base is 245.76 square root of 3 feet squared. So that's going to go up here. 2 times 245.76 square root of 3 plus the perimeter we already got. The perimeter was 76.8. And the height is 11. So I'm going to do all these calculations at once because I only want to round one time. I get a rounded answer of 1,696 point, if I round to the nearest hundredth, 0.14, and it's square feet. It is important to wait till the end to round. Some of you might be asking, could I do this another way? Yes, you could. You could feasibly do trigonometry. You could do Pythagorean theorem. I use special right triangles because I happen to notice that first. So there is other ways to get your apothem. But as long as you don't round until the very end, our answers should match exactly. All right, so cylinders are a special type of prism. They are a circle that's been stretched out. So let's look at a net of that. You would have a circle, but then you snip around the circle, and then you'd have the lateral edges, which would, when you unroll it, would look like something like this. And you're gonna have same vocab. You've got a base or bases. You're gonna have a radius. This is a lateral area. Same sort of stuff. Oh yeah, you'll have a height. But yeah, you've got basically a circle that's being stretched out. And then, make that edge behind it kind of dotted a little bit. So that right there is a cylinder. Okay, so you actually compute this the same way you do as the other shapes, other prisms. It's going to be, oh, there we go. Okay, sorry, thought I was out of lead. It's going to be 2 times base plus the perimeter times the height, but it's a circle involved. So instead, we're going to say surface area is equal to 2 times the area of the base. Well, the area of the base is going to be pi r squared plus the perimeter, which is the same thing as circumference, which is 2 pi r times the height. So if you just think about it, you can come up with that formula. It kind of looks kind of complicated when you write it all out. But yeah, it's just the area of a circle, circumference of a circle, got some heights in there, and you're good. Let's turn the page and knock out some examples right here. I would encourage you, if you feel like you got a handle on this, to work these out on your own and then go towards the end of the video so that you can check your answers, see if you've got them right. But for those of you that are needing a little more assistance, I'll work through them right now. Okay, so it looks like they've drawn the pictures for us. That was awful nice of them. They don't always do that. You're wrapping a poster in a cardboard cylinder. The cylinder has a height of 36 inches, which is already labeled, and a radius of 4 inches labeled. What is the minimum amount of cardboard needed to cover the poster, including the bases of the cylinder? This is a fancy way of saying find the surface area of the cylinder. So to find the surface area, oh, and by the way, for surface area, sometimes I'll write SA, sometimes I'll write S, it doesn't really matter, but surface area for a cylinder is going to be 2 times pi r squared plus the circumference, 2 pi r times the height. And it looks like we've got everything we need. We're just going to fill this in. So I got 320 pi inches squared. That's an exact answer, but oftentimes people want it rounded, so we'll give both. The other answer is 1,005.31 inches squared, rounded to the nearest hundredth. So there's two options. And yeah, that would be the minimum, right? That's with no excess, no excess. If you're actually wrapping something, you'd probably need to account for some excess. All right, example 4, find the height of the right cylinder, which has a surface area of 262.64 square centimeters. So what's interesting is they gave us some extra info in the picture. So that's nice. All right, so, and they told us the surface area, so I'm gonna write that down, 262.64. That's gonna be equal to 2 pi r, we have it, 3.8 centimeters, squared, plus 2 pi r, 3.8. But we are trying to find the height, so we're gonna have to solve for h here. Now class, again, I don't like to round until the very end. So I'm going to keep this all together. Let me do some simplifying first. I'm getting 28.88 pi here. And this back here, I'm getting 7.6 pi h. And then to get h by itself, I got to subtract this over, then divide. So it'll be 262.64 minus 28.88 pi divided by 7.6 pi. If you want to know a common mistake here, a common mistake is to see these pi's and think, oh my gosh, those pi's just cancel out. That is wrong. If you were to divide them here, you would also have to divide it here because you're distributing your division when there's addition or subtraction. And you're not able to distribute dividing by pi to both of them nicely. So don't do that. Don't cross the pi's out. That's not what happens here. Instead, I'm going to grab my calculator. And yeah, it turns out this is your answer in terms of pi. Delightful, huh? So let's go ahead and get our fraction answer. And yeah, oh, when you enter this in your calculator, divide by the 7.6 and also hit divide by pi. Or alternatively, put parentheses, division, parentheses, 7.6 pi. Oftentimes your calculator, you intend for it to be dividing by 7.6 pi. It thinks you're dividing by 7.6 and then dividing by pi. That's not accurate at all. So when you enter things in correctly, it looks like I just rounded to the nearest tenth on this. I'm cheating a little bit looking at my notes, but I got the height to be 7.2 centimeters, and I think that's rounded probably. So all right, well, let's go to the next one. Find the surface area of the right prism. So remember, surface area 2 times area of the base, plus the perimeter times the height. And we're running into a problem here. I've got the height, but I can't get the area of the bases just yet. I can't get the area, the perimeter just yet, because I'm missing some information. I'm missing a height right there. A tiny height, right? Not this height, but a tiny height. So I got a little bit of work to do. I'm in luck. It's a right triangle, so I'll do Pythagorean theorem. So 25 squared is equal to h squared plus 15 squared. And beep boop bop beep, I get 20 meters for the height. And now I'll be able to figure out everything. So to get big B, it's going to be 1/2 the base times the height. And my big B is 150 meters squared. And my perimeter that I'm going to need is going to be 20 plus 15 plus 25. So that's 35. Let's see, 35. And we added, oh yeah, that'll be 60. And we're ready to plug it into the big formula. Times the height, which was 38. And when you punch that all in, you should get 2,580 meters squared. On the next one, find the surface area of the cylinder. Well, surface area, 2 times pi r squared. Our radius is going to be 10. Careful now, right? 10 squared plus 2 pi, radius is 10, times the height of this thing, or the length of this thing. And yep, so your exact answer is going to be 720 pi square yards, or rounded to the nearest hundredth, 2,261 .95 yards squared. And lastly, Prism has a surface area, so they're giving us a surface area, but they want us to solve for x. So, yeah, surface area is 1848. That was a good year. Actually, don't know. I'm not a history guy. So 1848 is equal to 2 times the area of the base. Well, the area of the base is 8x. I don't know what, the area would be length times width, but I don't know what it is. I do know it's a rectangle, but that's it. So 8 times x. And then plus the perimeter. So if that's x, this is x, 8, 8. So it'd be 2x plus 16 times the height of this thing, which is 30. And we got ourselves an algebra problem. Distribute. Combine like terms. And solve for x. And you get 18 feet. All right, so class, hopefully you got these right. And check Canvas for the assignment. Thanks for having me.